David Smith here with one more Flipped Classroom math video. 3 tips before we start. Remember, you can pause the video at any time to catch up with your notes. You can also turn on the caption down below and watch my words go by on your screen. Lastly, if you feel like you can do this, you can speed up the playback and get through the video a little bit faster. I love the topic of today's lesson. Box and whisker plots. It just sounds so funny. Okay, so we're in our second lesson talking about presentation of data. So this is another graphical way to present your data, and it builds on a lot of things that we've been studying about data sets. So here you go. A box and whisker plot looks like this. So obviously here's the box, and here are the whiskers that extend out. And we're going to talk about these 5 important numbers that define the box and the whiskers. And underneath this plot, you always have a scale, and the scale will give you a range of values so you can assess what each of the numbers on the plot is. So let's take a look at those numbers. This should be familiar to you. 1, this is the minimum. This is the lowest value in the data set, pretty simple. 2 is the lower quartile, or Q1. So that's the lower quartile, Q1, we've used that. We can also use LQ for lower quartile. The third number, that's the median, not the mean, but the median. So that's the middle value of the data set. And I want to just call your attention, a lot of folks on tests and quizzes have been writing medium. It's not medium, it's median. The fourth number, the one on this side of the box, is the upper quartile, or Q3, which we call UQ. And then finally, we have the maximum. That's the biggest piece of data in our data set, and that's represented at this end. So the quartiles represent the half of the data, right? Because the median is the middle of the data. So this is the second 25%, and this is the third 25%. So in a way, the box and whisker plot divides the data into 4 chunks. So there's going to be the same amount of data points in here, as in here, as in here, as in here. Now the range of values of those data points can determine the shape of the box and whisker. You can have a box all the way down here, you can have a box all the way down here, you can have a box that's pretty big, you can have a box that's pretty tiny. And so you can see how this diagram very quickly gives you a sense of spread, center tendencies, things like that. All right, let's build our very own box and whisker plot based on some real data. So here's the data set that we're going to use for this one. You've already looked at this data set before in a previous lesson. We're looking at the ages of students in a university chemistry class. Okay, so we need our 5 magic numbers, our min, our lower quartile, our median, our upper quartile, and our max. So I love to do the easiest stuff first. My minimum is 17. That's just the smallest value. My maximum is 63. Woohoo! That was easy. Okay, now the next one to find is your median. That's the middle value. So we need to first find out how many data points total we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So that's an odd number. So we know that our median is going to be it's going to be one of the data points, and it's going to be exactly in the middle. And so we know that's going to be the 8th value. 1, 2, 3, 4, 5, 6, 7, 8. So 20 is our median. And we can check that there should be an equal number of values on each side, because the median value has to be the middle. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So indeed, cool. We checked that. We're good with our median. Now the lower quartile is the middle value of the lower half. So again, we've got odd numbers. It's kind of nice. 1, 2, 3, 4, 5, 6, 7. So that means it's going to be the 4th value. It's going to be our lower quartile. So that's this 18. I'm going to call this LQ up there, and that's 18. And then our upper quartile is also going to be the 4th value along. So 1, 2, 3, 4. Our upper quartile is 22. So right there. And let's write UQ right there. So pretty cool. All right, let's make our box and whisker plot now that we have our data. First thing to do is make our scale. Now, I'm going to suggest that instead of putting these numbers on there, that you use easy numbers to use that comprise your data. So I'm going to run my scale from 15 to 65, and that lets me go in fives. So this would be 15, and let's just try this. 20, 25, 30, 35, 40, 45, 50, 55, 60. That was pretty close, actually. I just need to creep this one in a little bit. So that's 65. And maybe I'll just label them every 10. So that's 25, 35, 45, 55. Maybe not the neatest scale, but it does the job. Okay, so now let's put our marks on our graph. Our min is 17. So that's going to be this whisker like that. It's going to be that vertical line. Remember, our box and whisker plot's going to look something like that, right? With min, lower quartile, we'll make a line in for the median, upper quartile, max. Okay, so we got our lower quartile is 17. I'm sorry, our min is 17. Our lower quartile is 18. So that we're going to have a line here, and then the box is going to go from the lower quartile to the upper quartile, which is 22. So where's the upper quartile? That's right there. So 22, we're going to get a line that goes out from that. So now I can make my box. And I need to put my mean inside my box. My mean is 20. So I can put that right there. There's my mean. And now my upper quartile, what is that? That's 22. Let's see, I made that a little too far. Oh no, I'm sorry, upper quartile, I have to go to my max now. So my max is all the way up here at 63. So there's my box and whisker. Minimum, lower quartile, median, upper quartile, max. All right, let's take a look at what our box plot tells us. First off, we've got a fairly spread out range, but let's take a look at the interquartile range because that will tell a very different story. The interquartile range is Q3, which is the upper bound, minus Q1, which is the lower bound. So that's going to be, Q3 is what? We've got 22 minus 18 is the lower quartile. So the IQR is just 4. Now the range of this data is quite a bit more. It's 17 minus, or 63 minus 17, quite a bigger number than the interquartile range. So you could say this data is really spread out quite a bit, but half of it is not very spread out. So that's going to lead you to suggesting something about this data. And I want you to pause the video and think real hard. What would we say in this kind of a situation that we could say about our data? Okay, the magic keyword is outliers. You can just look at this and you can see we've got 2 outliers. These numbers are very, very much bigger than all the other numbers. My guess is that this is a regular university situation, but you've got a couple people in class that are like going to college for the first time. A lot of people do that. They have a career, they retire from their career, and they go, you know, I always wanted to get a bachelor's degree at college, so they go. And when you go to college, you might see a few of those people here and there. I think it's awesome. All right, let's talk about outliers, because there's actually a formal way to find out if you have outliers or not. So we're going to do that. It's a pretty simple calculation. It's not in the formula booklet, so you really are going to need to know how to do this and remember that. So first off, let's bring over our important numbers from this same data set. We're working with the ages of students in the university chem class, and here we are. We had our min, lower quartile, medium, upper quartile, and max. And then we're also going to need our interquartile range, which was just calculated here as 4. Okay, so what we have to do to determine outliers, I think there's an E here. We have to find these things called the upper and lower bounds. So this is the upper bound, and this is the lower bound. And I know this lesson is kind of abbreviation heavy, so what you might do is make a little cheat sheet that you can use while you work the problems until they get memorized and you won't need that anymore. Okay, so The upper bound is just the upper quartile plus 1.5 times the interquartile range. That's all. And the lower bound is just the lower quartile minus 1.5 times the interquartile range. So let's do that for our data set. So this is going to be the upper quartile. So the upper bound is going to be 22 plus 1.5 times 4. So 1.5 times 4 is 6. So 6 plus 22 is 28. So that's the upper bound. So we have another stat for our data. The lower bound is just going to be the lower quartile, which in our case is 18 minus 1.5 times our interquartile range. So that's still 6. So 18 minus 6 is 12. So that's pretty straightforward. Our upper bound is 28 and our lower bound is 12. Now here's an interesting thing. How might you use these to determine outliers? All right, so here's a nice little quick definition for what outliers are. They are data points that fall outside the upper and or lower bounds. So if you have data points that are outside of these boundaries, they are considered outliers. So now you can say with certainty whether a data point is an outlier or not. So let's go back, take a look at our data set. In fact, I'm not going to write it back up here, but you might flip back through your notes and take a look at that data set and see if you can find out if or how many outliers we have and what they are. Okay, so on the bottom end, our smallest data point was 17. The lower bound is 12. So none of the data points on the low end are outliers. But the upper bound is 28. And as you recall, we had a data point that was 55 and we had a data point that was 63. So both of those are quite a bit further up from the upper bound. So that gives us certainty that these guys are called outliers. Let's do one more example to bring this practice home. So check this out. I've got some new data for you. Now we're using shoe sizes. And we're dividing our population up into females and males. So here are our European shoe sizes. These aren't American shoe sizes. And then we have our frequencies for both the males and the females. Okay, so we're going to crunch this data. We're going to make box plots for both populations and take a look at what we get. So your first task is to find, for the females, the 5 key values for your box plot. For the males, the same thing, the 5 values for your box plot. And I want you to use your calculator. You can do that. You don't have to write the data in an ordered list. You can basically just put your frequency table in your calculator and you can come up with these values. So go ahead, pause the video and do that. All right, let's see how you did. Here are my 5 key points for the female population. And here are my 5 key, not points, but data points, or actually calculations for the males. So hopefully you got that with your calculator. If you didn't get those, you want to try that again. Make sure that you're good at using your calculator to get these values. So now I want you to pause the video and calculate the interquartile range, the lower bound and the upper bound for both the males and the females. So go ahead and give that a try. All right, so here are my results. I have my interquartile range. Here's the steps. I've got 2 for my interquartile range for the females. And my lower bound is just the first quartile minus 1.5 times the interquartile range. So we get 34 for the lower bound, we get 42 for the upper bound, and via similar steps, I get the same interquartile range for the males. My upper bound for the males is going to be 35. My lower bound for the males is 35. My upper bound is 43. So I want you to pause the video right now and tell me whether we have any outliers, because that's what these bounds will help us determine. So look at your data and decide whether or not we have any outliers. Okay, if you picked up that we have 1 outlier for the males, you're right. This 49 here, it's beyond the upper bound for the boys, for the males. So that is an outlier. For the females, we don't have any of those. So we have 1 male at size 49. So that's our outlier, but we don't have any females in their upper bound category or beyond their upper bound. And the same thing by the lower bound. We have 1 right on the boundary, but not below it. So we have no outliers in the females. Okay. So now you have enough information right in here to draw a box and whisker for both the females and then one for the males. So do 2 box and whisker plots, put them on the same scale. So make your scale so that it encompasses all the data, and then put a box and whisker, say, along the top for the females and along the bottom below that for the males. So go ahead and give that a shot. This is a good practice. All right, let's see how you did. So here's my box and whisker plot. Let me scoot over this way. I've got my females up on the top. I've got my males on the bottom. I have my scale running from 32. My smallest size is 34, so that kind of encompasses it really well. And I zipped all the way up to 40. As you recall, our highest data point is 49, so that works pretty good. Notice some things. First off, I introduced a new notation here for showing outliers. My outlier is out there. Notice how I didn't include the outlier in the whisker, okay? So that kind of gives you a better way to visually compare the data excluding the outliers. So we can say some things about this data. We can compare these 2 data sets, the females and the males. First off, the interquartile range is the same. I mean, we know that from our calculations up in here. It's 2, but it's very easy to tell graphically that the interquartile range on both these populations is the same. It's just shifted 1. So the males have 1 size larger in the interquartile range. Also, the range of this data is about the same. We're ranging from here to here, here to here. It looks like the boys' range is a little less, like maybe 1 size less in the range, but it's very similar. Another thing is that the data is fairly symmetrical. The females have a little bit more below the median, and the males have a little bit more above the median, but it's pretty symmetrical. So we can say that. So all of these things are pretty evident from the box and whisker plot, and it's kind of nice in a way that we can compare 2 populations on the same graph and kind of check out the similarities and the differences.
Now that you've watched the video, take a moment to write down any remaining questions so you can bring them to our next class. Also remember that you can watch the video again to remind yourself of what we did or deepen your understanding. If you enjoyed yourself, please click like or subscribe.